quotient rule today, but I didn't prove it. And I knew if I tried to prove it, you would ask me, is this going to be in the test? And I would say, no, it's not going to be in the test. And then you would stop paying attention to me, and that's really annoying. But for those of you who do care about how this is true or why this is true, I would like to prove these two rules for you. So first off, we have the product rule. That says that if y is equal to f of x times g of x, that implies that the derivative is f of x times the derivative of g plus the derivative of f times g. That's what I'm trying to prove. So proof. Let y equal f of x times g of x. The definition of the derivative, y prime, is the limit as h approaches 0. So I need to stick x plus h into this. So that means I have f of x plus h, g of x plus h, minus f of x, g of x, and that's all over h. So what can I do with this? Well, I'm going to do a trick that we do a lot in math, add and subtract the same sort of thing. So I'm going to take f of x plus h, g of x plus h. I'm going to subtract f of x times g of x plus h. Wow, I'm running out of space. Plus, shoot, what should I do? Plus, I'm going to get rid of that, f of x times g of x plus h. So here, I added and subtracted the same thing, so that's just a 0. And then I still have f of x times g of x, and that's all over h. Oh lordy, that's a mess. Let's see if I can make it a little bit pretty on the next line. So what I'm going to do is in these first two terms, I'm going to suck out the g of x plus h. And these second two terms, I'm going to suck out the f of x. So, and I'll try to write a little smaller so I can fit it all in here. So in the first one, I will have g of x plus h times f of x plus h minus f of x. Then I have plus these two, I'm sucking out the f of x. I'm left with g of x plus h minus g of x. And that's all over h. Now notice this over h is f prime and the g's over h is the g prime. And since, okay, first let's break up the plus. I've got a fraction with a plus on top, so I could split it up into two fractions. So I'm going to have g of x plus h times f of x plus h minus f of x all over h, plus here I have f of x, all this, all over h. Now, as h goes to infinity, this is f prime, and this is g prime. I'll give myself one more line. So this times that, it's like two fractions I can pull apart. So I have g of x plus h times f of x plus h minus f of x all over h, plus f of x times g of x plus h minus g of x all over h. Okay, so let's rewrite that as a theorem. Or let me go to the next page and simplify this a little bit. So as h goes to 0, this becomes g of x times f prime of x plus f of x times g prime of x. So we have our product rule. And now the quotient rule. if y is equal to f of x over g of x, then the derivative, that's the bottom, times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. This horrible feeling I'm going to run out of space again. Let's see if I can find a smaller pen here. Okay, so we're going to say let y equal f of x over g of x. So y prime is the limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x all over h. Okay, so the first thing I'm going to do is bring these two fractions together. So I'll have f of x plus h times g of x minus f of x times g of x plus h over g of x plus h times g of x, major fraction bar, all over h. So, oh, this is a mess. Let's clean it up a bit. This is 1 over g of x plus h times g of x. I'm going to pull that out front because I know where I'm going, and I know that that's going to be my g of x squared on the bottom in a minute. So I'm going to leave it out here. Over here, and then I'm just going to rewrite this stuff so you can see what we're doing. Okay. Now we're going to pull that same trick, a little differently, but same trick. There's a lot of writing, g of x. So I have f of x plus h, g of x. I'm going to subtract f of x, g of x, then add f of x and g of x. Right, plunk in the middle here. Then I still have minus f of x, g of x plus h, all over h. Now notice, these two terms both have a g of x. I can suck it out. These two terms both have an f of x. I can suck that out. So that's what I'm going to do. Let's see, I've got the g of x times f of x plus h minus f of x. Now instead of pulling out a positive f of x, I'm going to pull out a negative f of x because I know where this is going. So now this term is negative and this one's positive, so I'll have g of x plus h minus g of x. And this is all over h. Now wait a minute. I have a minus here. I can put this over h and that over h. So let's do that. Now see what I have here. This, as h goes to infinity, this is f prime. And as h goes to infinity, this is g prime. And as h goes to 0, did I say infinity? Shoot, I meant to say 0. As h goes to 0, this is just g of x times g of x. So I don't have room on the bottom here. Let's turn it over. When you take the limit, you will have 1 over g of x times g of x, also known as g of x squared, times you have the g of x times f prime of x minus f of x g prime of x. And when you scooch them together and write them normally, you have the quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So that's the quotient rule. So now you've got to prove for the quotient rule and the product rule, and we actually proved the reciprocal rule thing in class today. So that's all. Thanks.